Okay, we've been talking about congruency. Now we're going to start talking about triangle similarity. Let's look at what makes two triangles similar. So if two polygons are similar, if all the corresponding angles are congruent and all corresponding pairs of sides are proportional. So real quick, what makes something proportional? We need it to have the same side ratio. So let's say you look at one triangle and you see that the side length is 12 and the corresponding side to the other triangle is 36. So we'd say 12 is to 36, or 1/3, and then let's say that you found another side of the triangle of 3 and it corresponded to a side with a 9. So we'd say 3 is to 9. And notice that these two side ratios are equal. So we could technically set these two proportions. And if you multiply these together, we get the same number as when we cross multiply. So for example, 12 times 9 is 108. And if I go the other way, 36 times 3, it's also 108. So when we cross multiply the two ratios in this with an equal sign like this, it's called a proportion. When we multiply these, we notice we get the same value when we cross multiply. This is what makes a proportion. These side ratios have to be equal. So we're going to be looking today at our proofs to see if the side ratios are equal. So in triangles, you can guarantee the triangles are similar with much less information. So here comes our three postulates that we're going to be learning today. The first one is called AA Similarity Theorem. That stands for angle, similarity theorem. This is the abbreviation for theorem. Two triangles are similar if they have two pair of corresponding congruent angles. And the way we would write this is AA Similarity Theorem. This is our symbol for similarity, and this is the abbreviation for theorem. So looking over at this image here, we can see that the 46 and the 46, this is already giving us one equal angle. And all we need is two angles. Do you notice any other angles in this picture? Good. Hopefully you saw these vertical angles are equal. So we can say that angle E is congruent to angle C. It was given in the image. And angle ABE is congruent to angle DBC by vertical angles are equal. Since we have two angles, we now have enough for similarity. We can say that triangle ABE is similar, there's the similar symbol, to triangle DBC by AA Similarity Theorem. Okay, this is our little mini proof for triangle similarity. Again, we can prove similarity with much less than congruency. So it's nice and short. All right, let's go look at the second postulate here. The second one is called side angle side similarity theorem. And this one says, hang on, let's write it all the way out. This one says that two triangles are similar if they have one pair of corresponding congruent angles and the two sides that form those angles are proportional to the corresponding sides in the other. So let's go do a little proof for this one. Notice again that they gave us this angle right here, and then they gave us two sides. So notice they gave us this 48 and this 12, We're going to be looking to see if that corresponding side is proportional, and they gave us this 32 and this 8. So let's go do a little bit of work here. So we're going to say side AC corresponds to side EC. And so we're going to say 48 is to 12, and we can tell that that reduces down to 4. Next, we're going to say that angle ACB is congruent to angle ECD that was given in the image. Finally, we're going to do the last side proportion. We're going to say length BC corresponds to length DC. And so that's a 32 is to 8, and that reduces down to 4. What's the reason for these two? We're going to say ratios of corresponding sides are equal. Ratios of corresponding sides are equal. So since they both came out to 4, we do have enough for similarity. So now we can say triangle ABC is similar to triangle EDC by side angle side similarity theorem. Triangle ABC is similar to triangle EDC by side angle side similarity theorem because we had a side and an angle and a side. Now notice, I'm going to put a little note up here. The angle has to be in between those two sides for this postulate to work. The angle has to be in between these two sides. If on the quiz, the angle is out here and it is not in between the two sides, you're going to say cannot be determined. It's not enough information for similarity. All right, last but not least, let's go down here and do the last one, side, side, side. Side, 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 similarity theorem uses the proportion of 3 sides. If all 3 sides in one triangle are two triangles are similar, if all 3 sides in one triangle are in the same proportion. Or are proportional to each other. So let's go see how this proof would look. Notice that this is the corresponding side to here. Notice that this is the corresponding side to here. And this is the corresponding side to here. So here I go with my 3 ratios. I'm going to say length BC compared to length DE is a 7 to 14 or 1/2. Next, I'm going to do CA compared to EF. That would be a 5 compared to 10, which reduces to 1/2. And finally, BA compared to DF. That would be an 8 is to 16, which is also a 1/2. Notice that all 3 have the same ratios of corresponding sides are equal. They all have a 1/2. Because all 3 ratios are the same, we can say triangle ABC is similar to triangle FDE by side, side, side similarity theorem. How'd you do?